How the universe will end, the science of cosmic doom. Part 1. The night sky has a secret. Beneath the calm night sky, under the quiet shimmer of stars, it's easy to imagine that the universe is eternal. That the stars we see tonight are the same stars that will shine forever. But the truth is far more dramatic, and far more unsettling. The universe had a beginning. And anything that has a beginning, must have an end. This is the story of that end. Not just the end of Earth. Not just the end of the Sun. But the end of galaxies, of time, of reality as we know it. Before we begin this journey to the final future, make sure to like, share, and subscribe to Uncovering Facts, where curiosity meets truth, and the biggest questions in existence finally get a voice. Now, look up at the stars one more time. Because by the end of this video, you'll never see them the same way again. Number 1. The cosmic clock starts ticking. The universe is not static. It is not frozen in time. It is a story unfolding. That story began around 13.8 billion years ago, with the Big Bang, not an explosion in space, but an expansion of space itself. In the first instant, time began. Space stretched. Energy filled the void. From that ocean of energy came particles. Particles formed atoms. Atoms formed stars, planets, and galaxies. And on at least one small world around one ordinary star, something called life emerged. But the Big Bang didn't just start the past. It started a clock. Every star that is born will die. Every galaxy that forms will fade. The universe is not a permanent home, it is a temporary event. And right now, we are living in its middle chapters. Part 2. The death of our world. We often imagine the end of the world as some sudden disaster, an asteroid, a war, a pandemic. But the true, final end of Earth is already written in the heart of the Sun. The Sun is a stable, middle-aged star. It has been burning for about 4.6 billion years. It turns hydrogen into helium, radiating light and heat into space, the reason Earth is alive. But the Sun's fuel is finite. And its death will be slow, cruel, and unstoppable. Number 2. A billion years of heat. Long before the Sun explodes or expands, Earth will become unrecognizable. In about 1 billion years, the Sun will shine about 10% brighter than it does today. That may not sound like much, but for Earth, it's fatal. A brighter Sun means higher temperatures, stronger evaporation, a runaway greenhouse effect. Oceans will begin to boil away. Water vapor, a powerful greenhouse gas, will trap even more heat. The sky will thicken, the ground will crack, and the seas that once carried ships and whales will turn into steam. Eventually, Earth's oceans will vanish. Without oceans, the planet loses its climate stability. Without water, complex life collapses. By this time, Earth is no longer the blue planet. It is a dry, scorched desert. Life as we know it, animals, plants, humans, cannot survive. Number 3. The red giant sun. Fast forward to about 5 billion years from now. The Sun's core runs out of hydrogen. The delicate balance between gravity pulling in and fusion pushing out begins to fail. The Sun swells into a red giant, its outer layers expanding outwards, growing hundreds of times larger. From space, it would look monstrous, its surface cooler, but its size enormous. The inner planets have no chance. Mercury is swallowed. Venus is swallowed. Earth sits precariously on the edge. Some models suggest the Sun's swollen atmosphere will engulf Earth entirely, vaporizing the planet. Others suggest Earth may just barely survive as a charred, airless rock, its surface molten, its history erased. Either way, this is the end of Earth as a world that once had oceans, forests, cities, and dreams. The home of humanity, if humanity still exists then, will be gone. Number 4. The White Dwarf Ghost. After the red giant phase, the Sun will shed its outer layers into space, forming a beautiful glowing shell of gas called a planetary nebula. At the center will remain the core, compressed into a tiny, dense remnant called a white dwarf. No more fusion. No more energy generation. Just leftover heat slowly leaking away. The Sun, once the giver of life, becomes a cosmic ghost. Over trillions of years, that white dwarf will cool and fade into a black dwarf, a cold, dead ember of a star. Our story with the Sun ends there. But the story of the universe continues. Part 3. The Expanding Universe. Beyond our little solar system, something much bigger is happening. The universe is expanding. Not just galaxies moving away, space itself is stretching. In the 1920s, astronomer Edwin Hubble discovered that distant galaxies are moving away from us. The farther they are, the faster they recede. This means the universe was once smaller, denser, and hotter, and it has been expanding ever since the Big Bang. But there is another twist: the expansion is not just continuing. It is accelerating. Some strange, invisible force, which scientists call dark energy, is pushing galaxies apart faster and faster. And the way this acceleration behaves will determine how the universe ends. Number 5. Fate 1. The Big Freeze, Heat Death. The first, and most widely supported, possibility is called the Big Freeze or Heat Death. In this scenario, dark energy continues its work. Galaxies drift further apart, fewer new stars form, existing stars burn through the last of their fuel let soon through time. In tens of billions of years, the last bright blue stars and white stars fade. Only long-lasting red dwarfs remain, glowing faint and dim. Then even those go out. The night sky becomes emptier. One by one, galaxies go dark. In an unimaginable stretch of time, far longer than the current age of the universe, matter clumps and falls into black holes. Black holes then dominate. But even black holes are not eternal. They slowly evaporate via Hawking radiation, leaking away their mass in a drizzle of particles. Over absurdly long timescales, up to 10 to the power of 100 years, even the largest black holes vanish. What remains? A thin mist of low-energy particles, spread across an enormous, cold, dark universe. No stars. No planets. No structure. No usable energy. Motion, life, information, all become impossible. The universe doesn't explode. It doesn't collapse. It simply empties out. This is the quiet, lonely ending, the Big Freeze. Number 6. Fate 2, the Big Rip. But what if dark energy does more than just stretch the universe? What if it intensifies? In the Big Rip scenario, dark energy grows stronger over time, overpowering all other forces. First, galaxies are torn away from each other. Then gravity can no longer hold galaxies together, stars drift apart. Later, even the pull between planets and their stars is overcome. Solar systems disintegrate. Planets fly loose into the void. In the final stages, dark energy becomes so dominant that it overcomes electromagnetic forces, the force that holds atoms together. Atoms themselves begin to rip apart. In the last tiny fraction of a second before the end, even subatomic particles are torn to pieces. Then, nothing. Space itself is shredded. This is the most violent, catastrophic ending of all, the universe ending not with a freeze, but with a tear. Number 7, Fate 3, the Big Crunch. Now, imagine the opposite. Imagine the expansion of the universe doesn't go on forever. Imagine it slows, stops, and reverses. In this scenario, gravity eventually overcomes expansion. Galaxies that were once racing away begin to fall back toward each other. The entire cosmos starts to contract. Galaxies collide in enormous waves of destruction. Black holes devour more and more matter. Temperatures rise as everything is compressed. Ultimately, the universe shrinks into a smaller and smaller volume. Until everything collapses into a single point, a singularity, infinitely hot and dense. Space and time themselves break down. This is the Big Crunch. The universe returns to where it started. Some theories suggest that after the crunch comes another bang. The death of one universe could be the birth of another. If that's true, then reality is not a line, it is a cycle. Endings are beginnings wearing the mask of destruction. Part 4. Stranger Dooms, Vacuum Decay and Quantum Death. The endings we've discussed so far are grand, large-scale, and slow. But there is a different kind of threat, small, sudden, and total. It comes from the world of quantum physics. Some theories suggest that our universe might not be in its most stable possible state. It could be in what physicists call a false vacuum, a kind of temporary configuration of the fundamental fields of nature. If somewhere in the vastness of space, a tiny region falls into a more stable state, a true vacuum, that region would create a bubble. That bubble would expand at the speed of light, rewriting the laws of physics as it goes. Inside the bubble, the forces of nature would be different, atoms might not form, chemistry might not work, life as we know it would be impossible, we would never see it coming. There would be no warning, no pain, no escape. One moment, everything is normal. The next moment, the universe as we know it simply stops. This is called vacuum decay. Is it likely? Probably not. Is it possible? According to some interpretations of physics, yes. The universe, in this view, is not only temporary, it is also fragile. Number 8, the black hole era and the death of matter. Even if vacuum decay never happens, and even if the universe does not tear or crunch, time itself is enough to destroy everything. Once the last stars die, and black holes take over, we enter what some call the black hole era. In that age, galaxies are just clusters of black holes and dead stars. Most matter has fallen into collapsed objects, the universe is dark, but not yet empty. Then, Hawking radiation begins to do its work, slowly, patiently, relentlessly. Black holes lose energy. They shrink. They evaporate. The largest black holes, with masses of billions of suns, might take up to 10 to the power of 100 years to completely fade. After the last black hole evaporates, the universe enters its final stretch, sometimes called the dark era. Only low-energy photons and elementary particles remain, scattered thinly across space. If protons, the building blocks of atoms, are unstable and eventually decay, then even the last traces of solid matter disappear. In this final epoch, the universe is not a place. It is a whisper. A blurry, empty background of almost nothing. This is cosmic old age. Part 5. Can anything survive this? At this point, a natural question arises. Can life, any life, survive the end? For humans, the first threat is not the big freeze or big rip. It is the sun and the fragility of Earth. To survive, we would need to leave our planet, spread to other worlds, learn to manipulate energy on stellar or galactic scales. Some scientists imagine civilizations that build Dyson spheres, megastructures that surround a star and capture most of its energy. Others imagine beings who abandon biology entirely, becoming digital minds, living on artificial substrates, powered by stars, black holes, or exotic physics. Future humans, or our descendants, could migrate from one star system to another, build habitats around long-lived red dwarf stars, orbit black holes, extracting energy from their spin, store consciousness in ways we can barely imagine today. We might even learn to manipulate space-time itself, creating wormholes, tunneling between regions of the universe, or escaping into new universes born from black holes. These ideas are speculative, but not impossible. They show one thing clearly: if we want the story of life to continue as long as physics allows, we must become more than a planetary species. We must become a cosmic species. Number 9. The limits of survival. Yet even the most advanced civilization faces a limit. When the last stars die, when no new energy can be extracted, when entropy reaches its maximum, there may simply be no way to continue. Information cannot be processed. Thought cannot occur. There is no fuel left for mind or machine. At that point, the universe becomes not just physically dead, but meaningfully dead. No observer remains to see it. No memory remains to recall what once was. This is the ultimate end, the end not just of matter, but of story. Part 6. What all of this means for us. All of this might sound terrifying, but there is another way to look at it. The fact that the universe will end one day makes the present moment infinitely precious. We exist in a rare window of cosmic history. Stars are shining, elements are forming, planets are habitable, life is possible. We are living in what some call the stelliferous era, the age of stars. This will not last forever, but it exists now. And within it, we exist. You, watching this video, thinking about the fate of the universe, feeling the weight of eternity. You are a part of the universe that has become self-aware. The atoms in your body were forged in dying stars. Now those atoms think, feel, and wonder how it will all end. There is something profoundly beautiful about that. Number 10. The gift of a finite universe. If the universe were eternal and unchanging, perhaps nothing would matter. But in a universe with limited time, every sunrise is a miracle, every breath is a privilege, every act of kindness, courage, and creativity is rare and unrepeatable. Endings are what give meaning to beginnings. We love stories because they end. We value life because it ends. We treasure moments because they will never come again. The universe is the ultimate story, with a beginning, middle, and end. We are a chapter in that story. And that alone is incredible. Part 7. The last look at the stars. One night, far in the future, some distant descendant of humanity, or some other form of mind, may stand under a sky very different from ours. Fewer stars. More darkness. Galaxies pulled away by expansion. They may look up and know that the universe is fading. They may whisper the same question we are asking now: how does it all end? Perhaps they will have found ways to escape. Perhaps they will choose to face it. Either way, they will owe their knowledge to those who asked first, people like you, alive today, daring to explore these ideas. We may never witness the universe's final moment, but by understanding it, we honor our place within it. We are not just passengers in the cosmos. We are its storytellers. Closing. Before the lights go out, the universe began in brilliance. It may end in ice, in fire, in collapse, or in a quantum whisper. We do not yet know which destiny awaits us. But we know this: right now, the stars still shine. Right now, Earth still turns. Right now, you are alive. And that is enough to make this moment worth everything. If this journey through time and fate has opened your mind, then help us keep the light of curiosity burning. Like this video to support more deep dive documentaries. Share it with someone who loves big questions. Subscribe to Uncovering Facts, where we travel from ancient empires to the edge of the universe and beyond. Tell us in the comments, which ending do you think is most likely: the big freeze, the big rip, the big crunch, or something stranger we haven't even imagined yet? Until next time, keep looking up. keep asking questions. And remember, we are the universe, thinking about itself, before the stars go out.